How rude of that video to cut me off. So last I'm going to make an XY table, and I'm going to test values to the left and to the right of the vertical asymptote. So whatever that number is, I'll do one number at least to the left and one number at least to the right. Okay, so let's try some. So I'm going to give you a couple of strategies on this first one. Of course, one of the first ideas is I can get a common denominator, and when I do, it's going to look like this. And then I notice, hey, this is a rational polynomial function. If I'm looking at x going to infinity, I'm thinking about the horizontal asymptote. And one way for me to think about that is to look at degree of the numerator and degree of the denominator. And I notice they're the same. So when they're the same, it's leading coefficient over leading coefficient. So this would be y equals 5. And the second way to think about it is, since the limit properties hold, and I can split when there's an addition and subtraction, so I split them. Now, as x goes to infinity, the limit of 5 is just 5. And then as x goes to infinity, remember back on one of your special rules on the last page, the limit of anything over x to some power is 0. And so again, I get 5. Again, a couple of ways to think about this one. I can treat it as the rational polynomial that he is, and I can look at the degree of the numerator and the degree of the denominator. They're both 1s, so since it's equal, I get leading coefficient over leading coefficient. So this value would be 2 over 1, which is 2. And that's really probably the most efficient, but another option is divide by the highest power, or excuse me, multiply by the reciprocal of the highest power. So I'd multiply everything by 1 over x. Keeping in mind I have to do that on top and bottom. So this is using my original limit value. And of course, as x goes to infinity, well, this beginning piece, these would cancel and I'd be left with 2. This second piece will turn into a 0. This beginning piece will turn into a 1 and another 0. So I'll end up with 2 over 1, which OMG is 2. And again, I could use both those strategies on this one. Of course, me liking the shortcut, I look at it and say, oh, it's a rational polynomial. I can look at the degree on top, the degree on bottom. Oh, look, the numerator is smaller. So therefore, as this goes to negative infinity, I'm going to get y equals 0. Because if the numerator degree is smaller than the denominator, I always get y equals 0. And using that same rule on this one, I notice, oh, the numerator is 3, the denominator is 2. When I look at the limit as x goes to infinity, I'm looking for a horizontal asymptote. So since the numerator is bigger, I can follow the rule that says there's no horizontal. I would get a slant on this one because that degree of the top is 1 more than the bottom, but it's not asking me about that. It's asking me about horizontal. So no horizontal. So now this one's a little cray-cray because I can't really tell the degree of the denominator. So this is one where I want to use the strategy of multiplying by 1, but I'm going to do it in the form of 1 over x. It's just that I'm going to be strategic on the bottom and call x the square root of x squared. And since I'm only looking at the positive version, this is the only one I'll need to try. And so I multiplied everything by here by 1 over x. And then here I just made sure I just kind of scooched it over, and then I put it all inside the same radical. So of course on top, x is canceled, and I'm left with 3 minus. Now, the limit as x goes to infinity for this piece will be 0. And on bottom, I'm going to have the square root of 2 plus 0. So this is 3 over the square root of 2. And remember in calculus, we don't simplify radicals in the denominator.